Lead code practice time. In this video, there are two goals. The first goal is to see how to solve this problem. Then we are going to put some code in, and the second goal is to see how we should behave in a real interview. So let's get started. So remember, in a real interview, the first goal is always try to understand the problem. If there is anything unclear, please bring up the clarification question, and at the same time think about some edge cases. So let's take a look at this question. Construct binary tree from preorder and inorder traversal. So given preorder and inorder traversal of a tree, construct the binary tree. And you may assume that duplicates don't exist in the tree. So for example, so given preorder is equal to this array and inorder is equal to this array, we are going to finally construct a binary tree like this. So in preorder, we have the root node as 3, and we find that the root node in the inorder is here, so we are sure that on the left side of 3 are from the left subtree, and on the right side are from the right subtree. So so that's pretty much about that's general idea how to solve this problem. That's a general direction, and to implement that, we will need to use recursion to solve this problem. Like, we follow the steps I just introduced. So like, you first find the root from the preorder, which is the first element, and then you find the place of the root node in the inorder, and then you can confirm what is the size of the left subtree, what is the size of the right subtree. So we do it recursively. So for finding a solution, and that's pretty much about the solution. And the runtime, if we have proper index built on, when I say index, it is about the number and the corresponding index within the inorder. So that one, it is going to give us the runtime as all of n, and n is the number of the nodes within the tree. So let's take a look. So for edge cases, from what I can think of, if preorder and inorder are not of equal size, or let's say preorder is none, then we are going to return none. Otherwise, I cannot think of any other edge cases. So let's say let's do some coding work now. So for coding, we care about the correctness of the code, the readability of the code, and of course, don't be too slow. So for this function, to start with, first of all, we are going to say if preorder is equal to none, or inorder is equal to a non-pointer, or preorder .length is equal to 0, or inorder .length is equal to 0, or preorder .length is not equal to inorder .length. So in all of those cases, we are going to return non-pointer for this. Otherwise, it starts our journey about the recursion. So let's see, we are going to define a helper function. Let's say it is called build tree, and we are going to pass in the preorder, the inorder, and we are going to have the, let's say we need to have the preorder start, and let's say just the p start, and then let's say p end. For inorder, we will have to have the I start and I end, and also we need to have the index map passed into it. So let's call it integer. This is integer. This is num inorder idx. So we need to construct a map for the Inorder. So we are going to have the, let's say, integer. This is num Inorder idx as a new hash map. So you're going to go over the Inorder array. So I is 0, I smaller than Inorder.length, and plus plus I. So we are going to have put num Inorder idx dot put Inorder I, and then I, because it says that there will be no duplicate numbers. So it doesn't matter for us to think about duplicates here. Then we are going to call build tree by passing in the preorder from 0 to preorder.length -1, and then this is Inorder starting from 0 to Inorder.length -1, and then we are going to pass in the num Inorder idx into it. So first of all, the exit of the recursion. So if pn is smaller than p start, then it is time for us to return a num pointer. Otherwise, we will need to have the root. So int so let's say the tree node root is equal to new tree node preorder p start. So that's the root node, and we need to build the left and right subtree accordingly. So let's say the length, let's say this is so we need to find the index for the root value. So let's say the root idx is equal to num Inorder idx dot get preorder this is p start. So in this case, we will be able to know the length of the left number of the nodes within left subtree and the number of nodes within right subtree. Let's say num nodes left is equal to root idx. So this is root idx within the Inorder. So it is going to be what is that? So it is going to be root idx minus the I start. So the num of the nodes within right is going to be root. It's gonna be so this is, what is that? In, okay, in minus root idx. So after we compute that, it is the time for us to call the recursive function. So root.left is equal to build tree for preorder. This is p start +1 until how many of them? So p until p start plus num nodes left. So yeah, I think the pn, because we have, yeah, I think it should be true. Yeah, and then it is Inorder. So for Inorder, the I start is so the I start is I start, and the right boundary, it is going to be root idx -1, and also we are going to pass in the num Inorder idx. And then the right subtree, it is going to be something like build tree, preorder. This is p start plus num nose left and plus 1 until the p end. And then Inorder, and we are going to start from root idx plus 1, and then it is until the I end. And then we pass in the num Inorder idx. And then finally we return the root. So that's pretty much it about the code. Let's do some testing. So for testing, usually you go through a simple example explaining how this piece of code is going to work. So let's use this example. Let's see if there is any bug we need to fix within the code. So first of all, it is not going to jump into this edge case. It doesn't meet the edge case, so we are not going to return none. And then we are going to form the num Inorder idx for each of the number. Sure. And then we are going to call this recursive function build tree. So first of all, we start to get the root, which is p start, this one, and we get the num Inorder idx. So the index for 3 within the Inorder is here, which is 1, and we have the num of the nodes within left is equal to 1 minus 0, which is 1, and for the num within the number of the nodes within right, it is 0, 1, 2, 3, 4, 4 minus 1, which is 3. Alright, so until now everything looks good, and when we call the build tree, it's preorder from p start plus 1, which is here, to p start plus num nodes on the left, which is also here. And for this one, we are going to call p start plus num nodes left plus 1, which is from here to the p end. So this seems to be good on both left and right for the preorder. And let's see the Inorder. So Inorder, of course, we find the root index. For the left subtree, it is going to be I start to root idx minus 1. For the right subtree is root idx plus 1 to I n. Okay, so I think until now everything looks good. Let's give it a shot. Okay, it seems like it works. Let's do a summation. Alright, so everything works here, and that's it for this coding question. So if you have any question about this coding puzzle or about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.